All right. Well, good morning, good afternoon, everyone. I hope you guys are doing great. And thank you so much for joining for today's webinar. And for today's webinar, please welcome Dubem. He is a security researcher at Corelight Labs, and he will be presenting on machine learning analysis in Zeek. So welcome, Dubem, and take it away.
Thanks, Fatima. Um, welcome everybody. Thanks for coming. Uh, this talk is titled Integrating Machine Learning Analysis in Zeek, but in fact, it should be integrating real-time, context-aware machine learning analysis in Zeek. And just hang with me, we'll unpack this in a minute. First, my name is Dubem. I'm a security researcher and data scientist at Corelight. And that means that I spend a lot of time thinking about ways to use data science and machine learning to protect the enterprise network. I'm a big fan of Zeek and Bernese Mountain Dogs. There's zero correlation between those two. I just thought to share, honestly. Um, Anyways, here's what we're going to cover today. I'll start off with a brief recap of Zeek. It's going to be high level. Then I'll talk about the traditional way Zeek is employed for machine learning use cases. Then we'll delve into three ways to do that same ML inference closer to the source, i.e. Zeek events. And that's by no means saying there are just three ways to do this. Just for the sake of time, I'm just going to limit it to three. We'll weigh the pros and cons of each of these. We'll discuss some key considerations and takeaways. And then, of course, we'll have time for questions. But at any point, please feel free to leave questions in the Q&A section. And with that, let's get started. So here's how Zeek works. Packets coming from live network traffic or a packet capture file, right? The packets get analyzed within the event engine by protocol analyzer. And this is where Zeek tries to figure out the underlying protocols and then sends them off to an event queue. The event engine then generates events based on what it sees and in the order it sees them. These events are what Zeek scripts handle. That's where you define what to do, including what to log using Zeek's custom scripting language. And now here's a typical machine learning workflow. There are a few ways people consume Zeek logs for post hoc machine learning analysis today, but usually some version of streaming or holding Zeek logs in the secondary store, processing those Zeek logs to get them in the right format before feeding the process logs into an ML engine. The ML engine first learns a model during training phase, and this part may or may not be offline. And then the trained model is used for analysis and inference, or scoring, if you will, when deployed. What I need you to consider is that in this design, control and data tend to flow in one direction, right? Zeek has no further context for what the downstream analysis uncovers. And honestly, that's fine for most use cases, but what if we maintain context by closing this loop? So an unbroken stream of real-time machine learning powered analysis that begins and ends in Zeek, right? This real-time feedback could drive advanced detection logging. It can be used to enrich existing Zeek logs and also to raise targeted notices. There's the added cost advantage, of course, to using already available Zeek resource to extend to machine learning inference. So broadly speaking, engineering this feedback loop can require two separate systems talking to each other, as this diagram illustrates, or the inference engine can be built right inside of Zeek. And I'll touch on both instances. Oh, and one more thing, just to keep the focus of this talk on Zeek, I'll focus on the inference and deployment aspects of Zeek to ML workflow. We won't bother about the details of machine learning, model training, and algorithm selection, all the cool stuff. But I'm always happy to chat about that offline if you're interested. And with that, let's get into the first. So I said I'll focus on three ways to implement this context-aware machine learning analysis in Zeek. The first is using Zeek plugins and built-in functions, and I'll tell a story of how this came about. So I've been part of Corelight Labs over 5 years, and one of my early projects at Corelight was writing a package to detect DOH, as a DNS over HTTPS traffic. At the time, we were building out the encrypted traffic collection. This was a suite of packages to detect encryption and encrypted activities on the network. Um, we were some ways into the collection, but DOH was particularly an interesting one, right? Because back then, DOH was kind of new. And so we ended up with initially a Zeek script that basically matched TLS server names and IP addresses against a handful of publicly known DOH servers. And this package worked great for as long as DOH wasn't exciting, which honestly was like 2 seconds. Because as soon as DOH adoption increased and the server landscape expanded, it was clear that we needed something more scalable, something more generic. It also didn't help that private DOH servers were on the rise, and some public servers host multiple resources at the same address. And then there was this incident involving C2 communication over DOH. So it was a race, and in this race against time to build a generic DOH detector, we analyzed hundreds of millions of DOH traffic patterns across environments, multiple environments. I'm talking colleges, healthcare, financial institutions, just name it. We identified key features indicative of DOH, but the thing was that the feature complexity was just too much for a rule-based approach. So we thought, hey, we need machine learning for this. But there wasn't really a way to do machine learning directly in Zeek back then, at least not that I'm aware of. So what we did was we fired up a Jupyter notebook. And for folks who are not aware, Jupyter notebook is pretty much the data scientist toolkit to build out data analysis. So what we did was we used this notebook to train a machine learning model in Python. And it didn't take long to get a great model. But once we did, we then had to get this Python model working in Zeek on live traffic, right? And that's when we turned to Zeek plugins as a way to bundle our Python model object and have it available to the script learn through built-in functions called to the model plugin. So now let's go into how exactly plugins work. Now, I know I showed a version of the Zeek architecture a few slides back, but to really appreciate Zeek's extensibility, you've really got to zoom in. Zeek provides a plugin API that allows the addition of new features without altering the core system. So think new package sources, new protocol parsers, file analyzers, all of these are pluggable. You can add new log writers like to Kafka, Elasticsearch, Splunk, etc. And built-in functions provide a way to access plugins from the script level. Essentially, built-in functions are written in C++, so they're super fast. And I guess the idea is that they create an abstraction layer between Zeek script and C++ code. So it's kind of a glue to help Zeek communicate with C++ level stuff. So actually, a number of functions you interact with as a Zeek developer are made available to the script layer this way. And so it just made sense to leverage this already existing tool to embed our first lightweight machine learning model. To be honest, getting an ML model working in Zeek as a built-in function isn't exactly straightforward because you see, ML models trained in Python are typically saved in a different format from what Zeek is familiar with, right? And built-in functions require C++. But luckily, there are a number of open source tools to transpile or convert Python model objects to C++ code. And once you have the C++ code implementation of the model, you need to initialize it as an opaque Zeek type. Now, the opaque type in Zeek is how Zeek handles complex data or data that originates from outside Zeek scripting layer. It essentially hides the internal details of the data structure, hence opaque, and allows access to the structure from the script by calling a built-in function or BIF. But essentially, Zeek scripting layer doesn't directly know or care about the underlying representation of the data. Instead, scripts interact with the opaque value through built-in functions in such a way that the actual classification operation, in our case, is done at the C++ level. So it's fast, and as far as the script layer is concerned, it's simple. And just like that, you have a built-in machine learning classifier function you can call on Zeek events in real time. But with everything, there were challenges, and we had to overcome these challenges. One of the first one is, honestly, of all the ways to embed machine learning in Zeek, this is the one with the highest probability of shooting one's foot off, figuratively, of course, because you need a good understanding of Zeek language, C++, Python, software engineering. You might need to take one or two charm classes at Hogwarts to figure this stuff out. But you could also just ask the folks in a Zeek Slack workspace, honestly. Another thing was, the caveat is that not all Python ML models translate seamlessly to C++. So the complex architectures like deep learning models can be difficult to accurately convert. So it takes some thought to develop a plugin that allows this sort of, I guess, transparent usability inside of Zeek, right? And also just being able to scale your models in the sense of adding new models and also updating models and having to rewrite plugins or update the plugin code is non-trivial. So since then, we've had a whole bunch of Python models to run, right? And just for the challenges I mentioned earlier, we sought a more flexible and faster to production approach. And that led us to the Broker framework. And now I'll talk about the second way to integrate machine learning via Broker. But before I go ahead, any questions? I don't see any questions in the chat. Okay. So if you're running Zeek in a high volume environment, you'll probably be running a cluster of Zeek instances, and they all communicate with each other. The communication is powered by a pub sub middleware called Broker. For folks who are not familiar with Broker, the Broker library is responsible for cross-process communication between Zeek instances and also between Zeek and other external processes. So, and also Broker provides data stores, but we won't get into that. For our use case, we'll limit our concern to the messaging system. The library itself uses CAF internally for connecting nodes and exchanging data. But on top of that, Broker introduces a topic-based publish subscribe model. So what we have with Broker is the ability to send data and events back and forth between our non-Zeek process and ML inference application and the Zeek scripting layer. So more detail, like any pub sub model, endpoints represent either side of the communication in Broker, the sender and the receiver. Endpoints send messages by publishing data under a specific topic. Endpoints receive data by subscribing to topics of interest. So it's sort of like a newsletter, subscribing to a newsletter. And there are a few ways to talk to Broker. There's the native C++, there's a Python bindings, or you could talk WebSockets. And my understanding is this is the preferred way, WebSockets. I also understand that we might be moving into a world, a pluggable world where broker itself is uh, pluggable, and so you could bring your own MQ, message queue. If zero MQ is what you are familiar with and you like, you could always just replace one of these with your preferred messaging engine. Uh, but I will like to focus on Python bindings, mostly because I am partial to Python. Um, but it's in no way the only or the best way to do this. So one of the interesting advantages of doing ML in Zeek using Broker is the isolation, right? By running the ML analysis in a separate app, we keep things nice and contained. If something goes wrong with the ML application, it shouldn't take down Zeek. Yet, yet, even though they're separate, Broker still lets these applications communicate seamlessly. So Zeek maintains connection context while being enriched by ML outputs. And since it's a standalone system, it could make sense to manage the ML app in a Dockerized environment or better still, Kubernetes, depending on your orchestration needs. Um, and that should allow the application to scale with multiple containers engaging Zeek via Broker. So what I mean is you could have multiple containers or pods, and they could all be doing some sort of machine learning scoring and communicate with the Zeek engine via Broker. Um, and also in theory, you could outsource the ML analysis to a serverless compute like AWS Lambda. Honestly, the cloud is the limit. So you you could just go crazy with this stuff. Um, and again, I I I just want to point out the fact that there will always be challenges in this. And in our case, one was Zeek maintains connection state, right? If the ML result arrives after Zeek has removed the connection state, it may be difficult to achieve the context goal we set out. So one way we solved this was to preserve the connection state for a little longer. You could also maintain the state information separate from the event. So things like UIDs and connection IDs, you could send that off to the ML engine itself and receive it back with the ML scored and enriching that information. Um, Another is that the high Zeek event rates and also resource contention could lead to queue overflow, increased latency, and memory pressure. Here, you could implement a robust event pre-filter within Zeek. Um, You could also, caching is also a good solution here, or you could rate limit by applying back pressure. I know there's this broker option you can set uh, your overflow policy. And then finally, you could also just increase the buffer size. There's also an option to increase broker's buffer size. I believe the by default it's 2 kilobytes. I might be wrong, but I believe that's what it is. Um, And then finally, the overhead of individual serialization operations can be significant in Zeek. That's the sending back and forth from broker from broker in Zeek to the Python application. But you could simply resolve this with batching. And ML models typically perform better with batch processing anyway. But it's important to note that choosing the optimal batch size isn't exact science because too large and you may reduce serialization overhead, but increase latency. Um, I guess it goes without saying that your Python application should also be written in such a way that it runs optimally for any of this to even make sense in the first place. Yeah. So in summary, um, Broker helped us scale our machine learning use case. And it was a lot more flexible and a lot easier than the first option, using plugins and built-in functions. But finally, as a bonus, I want to give a shout out to Zeek.js. But first, let me see if we have any questions. None in the chat. Do we have any questions from folks?
Nope, I don't see any raised hands.
Awesome. Okay, so in a nutshell, Zeek.js is a plugin. It's a IO source plugin, right? And what it does is lets you run JavaScript or Node.js right inside of Zeek. It's relatively new, but I've already seen really cool applications. So why not machine learning? Um, so here's how it works. Zeek loads and executes the JS script, and these Zeek JS scripts can listen for Zeek events. They can access and manipulate Zeek's internal states, and they can take action like create and modify events and interact with other systems. And I have this funny story about Seth Hall and Zeek JS. Seth Hall is one of the founding members of Zeek. I was flying to LA from SF, San Francisco, a few years back when he messaged me about using it for machine learning, like using Zeek.js for machine learning. Um, so we jumped on a Zoom call in the airport while I was waiting to board and talked about it. And by the time I landed, the first message I received was from Seth saying he had gotten it to work. Now, granted, it's Seth, but it still shows how surprisingly straightforward it is to serve machine learning via Zeek.js. Um, again, you may need to convert the model to a JSON format, but there's a TensorFlow page with detailed instructions on how to do this. And the open source transpilers converters I mentioned earlier also have the option to convert models to JavaScript. And once that's done, all you need to do is load the model and call the predict function. And it's honestly as simple as that. I think a message came in. Yeah, Christian, it's set. So, um, anyways, okay. So I'm going to leave this up here while I emphasize that the best method for integrating machine learning analysis in Zeek depends on the specific needs of your situation. Um, there's not one single solution that fits every scenario. You should consider the unique requirements of your use case and your environment to choose the most appropriate approach. Um, and when choosing the right tool, consider these factors. For raw speed and simple traditional machine learning analysis, built-in functions are great, but they are complex to work with. Uh, Broker with Python offers a balance of flexibility and performance, especially for more complex machine learning. But you have to be careful about overloading Broker. My advice is to have every bit of your system just oozing metrics that you can track for the health um, of the entire system. Um, and then Zeek.js is exciting and flexible, but it's still experimental, and I'm really excited about it. So to wrap this all up, um, real-time context-aware machine learning analysis in Zeek is a significant force multiplier. So the ability to exercise granular control over your machine learning analysis is powerful. And then you have access, you can access raw protocol data through Zeek events for little to no cost, feed that data to an inference function, all the while maintaining connection context. Um, it blows my mind sometimes still. Um, and it also works great for air-gapped environments. One of our use cases was actually like it was motivated by trying to uh, provide machine learning to environments that are siloed, sequestered from the internet, and this worked perfectly. any of these would work perfectly. But most importantly, the mechanisms, the tools required to do machine learning analysis in Zeek already exist in Zeek. And that's my time, folks. So thanks for yours, and I will take questions if any. Are these ML inference running the same process with Zeek, and can they access Zeek memory objects? Um, I guess it depends on the methods, but the ones that are integrated into Zeek definitely can access uh, Zeek objects. That's the whole point of having them embedded inside of Zeek, right? Which means you have to be careful about how you architect them in such a way that they don't end up I guess interrupting other Zeek processes. Can the broker approach be used if I only have a single node? Of course, you can. You can. I think the idea of me setting it up as having multiple nodes is that's how most folks use broker today. But you definitely can use broker to connect to your ML engine on a single node. Um, However, in a high environment, in a high event environment, you probably will be better suited with distributing a lot of that work across multiple uh, instances. Backdoors in ML model. That's an issue, especially in our field that we have to uh, reconcile with every day. So it's up to the developer, in this sense, the machine learning developer, to make sure that the models are in a good state for you to introduce them into an environment like Zeek, right? Yeah, it's it's a potent question. It's a really good question, but it's something we struggle with every day.
I just wanted to point out that if folks want to ask questions and rather than typing it in, I can pretty much allow them to talk and ask you the questions directly to them. Okay, so
I see a
Yes.
question Q&A. Give me a second to answer this one. Can I do the machine learning prediction via Zeek.js and forward the prediction to Kafka Broker? Yes, yes. You can. So nothing stops you from setting up your connection in such a way that you can offload the result of your detection to some other uh, node outside of Zeek, right? This was just one example. So really, the idea is that you can have that connection context that Zeek provides. You can do machine learning while maintaining that context. And now what you do with the end product is up to you. You could send it off to a third-party system. You could keep it in Zeek, establish a new event, raise a new event that you could then use to do further analysis inside of Zeek. It's honestly up to your design and your requirements.
Yeah, thank you for the talk. Can you hear me?
Yes, I can hear you.
Yeah, I have a question about the overhead. So what are the performance overhead of these ML model in Zeek in terms of latency and event parsing?
That's a really good question. I can speak from my experience, right? In the very early stages, that was our biggest concern, just the overhead. And also how impactful it would be on the brother Zeek engine and Zeek's primary use case, which is network monitoring, right? And I can tell you that in the beginning, there was a ton of drop packets, but then we started to, tighten some screws. Like I mentioned earlier, right? If you have the right caching in place on the Zeek side, if you have batching in place, there are a few things you could do to optimize the way this runs. And in our case, we got to the point where we weren't dropping packets anymore, and we were still doing a ton of um, model inferencing. And by a ton, I mean multiple models were running at the same time. But does that answer your question?
Yes, yes. Thank you.
You're welcome. Christian Kryberg is in chat telling me kudos for figuring out all the trade-offs, but he fails to add that he was also very helpful while I was trying to figure all this out, because my understanding again is that no one had gone down this route, putting machine learning on a live running Zeek environment. Uh, and so I disturbed him a lot in this time, and he was really helpful. So thank you, Christian.
Dubem, I have a last question. So since we are talking about the live traffic, how much of the traffic you are talking about, like when you tested the like it's a 10, is it like a 10 gig or network, or how big of the network are we talking about here when we are talking about testing live Zeek traffic in machine learning?
Yeah. It ranges, honestly. And when I say we, I mean Corelight. Our customers range from like 5 team companies to, the Fortune 500, right? And all of these customers today run some piece of Corelight equipment that's doing machine learning on their live traffic. So if that sort of gives you an idea of how large of an environment these models are running in, and I'm yet to hear anyone say, hey, we need to turn this off. This is killing us. So yeah, we've put it on the largest of possible networks, and it works fine.
That makes sense. So that sounds like it scales pretty well with the network traffic, and it doesn't have a lot of overload on the network performance.
Absolutely.
Sure.
Yes. I didn't. So the question here is, do you have any pre-built machine learning model trained using network traffic labeled with various threads? I didn't touch on the machine learning piece on purpose, but yes. So most of our training is done offline, right? We have access to a ton of data, labeled data or otherwise, thanks to Zeek itself, because you can actually just write. So usually what I do personally is I write like a scrappy package, Zeek package, to gather training data for me. So it doesn't have to be accurate in terms of labeling, right? I can do the post-process labeling myself, but I write a Zeek package to build me a training data, and then I take that data out to my Jupyter notebook or whatever I work with, and I train offline, and then take that model object and build out the machine learning engine with the model object. How encrypted traffic affecting the accuracy of the ML model? So the idea of using the right tool for the job was exactly this, the fact that we've gotten to a point in network security and security as a whole where encryption sort of blunts some of the heretofore effective tools or approaches to detecting certain activities on the network. And so it's time to hand over to something that just works better. And what I mean by that is machine learning, right? So we approached machine learning because we thought it was possibly the best way. And I'm trying to pick my words because I have a background in network security, but I also have a background in data science. But I'm one of those school of thought people who is like, just because you have a hammer doesn't mean it's a nail. Um, in this case, machine learning just seemed like the best approach to detect encrypted traffic, and it did it really well, way better than other approaches that we considered, or at least more. It scaled more in the sense that we were catching things that we hadn't seen before. Take, for example, the DOH example I mentioned. We were actually finding new DOH servers that no one else had put in any of these curated lists online. Another question says, did you consider reading the Zeek logs and using something like that to ingest the logs into data frames? I did. I did. I think that is really, really, it's a wonderful package. I used it a lot in the beginning. Um, it it works really well I don't know if folks know what that is, but it's sort of like if you are familiar with pandas, that is it sort of builds on pandas, but it's very Zeek specific, right? So you could just feed it Zeek logs and it understands the format of the logs, and you have your data frame with all the Zeek fields in the right type. And so that helped me a lot. And most folks, I'm sure, still use that. In our case, we focus more on what was inside of the events, if that makes sense. So we were teasing out packet information directly from Zeek events, which is sort of kind of like two different things. But I definitely used that earlier on for uh, data analysis of the packages I had built for the training phase. And someone is asking what I think of using GPUs to accelerate packet parsing and ML inference. GPUs are wonderful for some use cases, and in others, they don't necessarily uh, make things faster or in any sense more optimal, especially for edge processing. Um, I think I think there's a place for GPUs. I just don't know that, like, especially in one case, I was having a conversation with someone and we ran some numbers and it just didn't seem like it did much to help. And then when you start to think about skills and how much more you have to quote things because it now has a GPU, you start to weigh the pros and cons of it. But this is in no sense saying GPUs aren't good. I just think sometimes you might fare well with CPUs if you're not having to deal with too much metrics computations. This has been fun. Um, No more questions? Come on, guys. Okay. Thank you very much, guys. This was
Dubem, I'm sorry if you answered that, but I think there was a question in the Q&A about the deeper dive presentation ever coming out.
oh, sorry. Christoph, is there a deeper? So actually, not necessarily a presentation, but I am working on a blog post that goes deeper into all of these points and potentially has some, I guess, dummy code. So watch out for that. Once it's out, I'll post it in the Zeek Slack workspace. So just keep an eye out for that. Thanks, David. Our trained models, someone's asking if our trained models are available for public access. They are proprietary Corelight property. Yeah, available if you access them through a Corelight sensor. Well, I don't think my team is averse to building a model and open sourcing it. It just depends on the needs and requirements, I guess.
Okay, since there are no more questions, thank you very, very much for this great talk, and thank you everyone for attending and joining us for today. And currently we don't have any more of these webinars planned, but if we do, we'll announce it on our typical channels. So thanks again.
Thanks, everyone. Thanks, Dubem. Take care.